College Algebra, Topic 6.1, Addendum. Okay, number 2 says, the area of a circle varies directly with the square of its radius. The area of a circle varies directly with the square of its radius. The area of a circle, so we'll use A, and varies directly means that we're going to take the constant and multiply it with the radius. So varies directly with the radius. Now, it says the square of the radius, so we're going to add a second power right here. Okay, that's it. The area of a circle varies directly with the square of its radius. Then they tell us that a circle with a radius of 20, circle with a radius, let's put an R there, a radius of 20 centimeters. It's a bad looking R. Okay, has an area of 1256 centimeters squared. Okay, so we're told that if the radius is 20 centimeters, the area is going to be 1256. Well, using that information, I'm going to write in 1256 for my area, and constant, and 20 squared for my R squared. Now, 20 squared will be 400. If I divide both sides by 400, my constant ends up being 3.14. And the last part says, what is the area of a circle with a radius of 25 centimeters? What is the area of a circle with a radius of 25 centimeters? So we have area now equals 3.14 R squared. This is the formula that we were looking for, because we need to know the constant. Well, if we now know that the constant is 1.4 and we have a radius of 25 squared centimeters, let's see, 25 times 25, that's 625, and then 625 multiplied by 3.14. Let's see what that's going to be. Let's see here. I think that'll be a 1 and 9, 6, 7.5, I believe, centimeters squared. Okay, I hope I thought of that right. Got that right. So 19.65, and this is higher than 12, so yeah, I'm pretty sure that's correct. That's the area. Okay, number 3. The speed of a car is inversely proportional to the time it takes to travel. The speed of a car is inversely proportional to the time it takes to travel. So the speed of a car, we'll use S. Inversely proportional means that the constant is being divided, and it's inversely proportional to the time. The constant is being divided by time t. And we're told that a car is traveling 60 miles per hour, and it is traveling for 30 minutes. 30 minutes is about a half an hour. So the speed right now is 60 miles an hour, and the time is a half an hour, which we'll put a 0.5 here. So using this speed, miles per hour, and a half an hour here, I have that 60 equals the constant over 0.5. If I put a 1 under here, I can multiply the 0.5 times the 60, and we get 0.5 times 60 equals the constant, which means that the constant is 30. Now, from that, we have that S equals 30 all over the time. Now, the question is, how long would it take if someone was driving 75 miles an hour? What's the time for 75 miles an hour? So we'll put 75 miles an hour in for the speed, and we'll look for t this time. What I'm going to do is put a 1 under the 75, and I can replace the 75 with the t and the t with the 75. So this will be t equals 30 all over 75. Alright, now let's see, to reduce this. 5 goes into both of these. 5 goes into 30 6 times, and there's a factor of 5 that goes into 75 15 times. And these both have a factor of 3, so I can take the factor of 3 out. That leaves 2 and 5. It's 2 over 5, that's about 0.4. That's less than a half an hour. Okay, 0.5 would be a half an hour. So if you're going 75 miles an hour, it's still just about a half an hour, but just a little less.